Okay guys, so sorry for the really late help for this assignment. I have been busy doing some college work and also I've been just plain busy. So I do apologize for this. But here's a question nonetheless. I am gonna get this one straight out of the book, so it should be similar to the questions that you guys were given. So the question reads, a compound is analyzed and found to contain 25.9% nitrogen and 74.1 oxygen. What is the empirical formula of the compound? So for these questions, we're just going to be basically looking for empirical formula. We're not going to concentrate, or we're not going to really look into more of the molecular formula. Right now, we're just going to be looking at the empirical formula. Alright, so in the question, you are basically given just percentages just like so, with 25.9% being of nitrogen and 74.1 being for oxygen. The whole point of this question is to find the little numbers here, or the subscripts you will have for the empirical formula or the compound that you're looking for. So basically you're just trying to figure out what is the little number where the question mark belongs in the compound itself. So the first one that we're going to do, because you're going to do them kind of in a way together, is nitrogen. So what you're going to do with nitrogen is you're going to get this number and change it into gram. So you're going to do this: 25.9 grams times, and then the line. Now, you do not know how many nitrogens you have, so we are going to assume we only have one. So the molar mass of one nitrogen is going to be that of 14.0 grams, because that is the molecular weight of one nitrogen atom over 1 mole. The same thing will happen for oxygen, so we get 74.1 grams times, and then the line, and the molecular weight of oxygen is going to be that of 16.0 grams of oxygen. On top will be 10 mole. Now, let us just do the math. So, for the first one, we're going to do 25.9 times 1, which should be the same thing, divided by 14, which should give you that an answer of 1.85 moles of nitrogen. The other one is 74.1 times 1 divided by 16, which should give you about 4.63 mole of oxygen. Now that we got the moles for each element, for nitrogen is going to be 1.85 moles of nitrogen, and for oxygen 4.63 moles of oxygen. Now we could kind of do the simple step where it's kind of confusing, but this is the only way that you're going to be able to do it. So you are going to decide between these two which one is the smallest one. Obviously, in a scale of 0 through 10, or let's say whatever number scale you're looking at, 1.85 is obviously smaller than 4.63. So for nitrogen, let's focus more on nitrogen first. You're going to do 1.85 over 1.85. Now, it is going to be 1.85 mole of the nitrogen over just the smallest number, okay? We're not going to really look much into other things, so 1.85 over 1.85 is going to end up to be 1 mole of nitrogen, because any number over its original number, or the same number, is going to be that for 1. Now for oxygen, instead of putting 1.85 on top, we're going to put 4.63 moles of oxygen, and in the bottom you will again put the smallest number out of those two, being 1.85. When you do the math, that would be 4.63 divided by 1.85 should give us relatively about 2.5 moles of oxygen. Now note, in a formula or in a compound, nitrogen could be, yes, as a 1, so we could leave it as N1 or N, then O, 2.5. Now, We don't want it as a decimal point, so what we need to do is multiply both by 2, because we all know that 2.5 times 2 is going to equal that of 5, while 1 times 2 is going to be that of 2. So in a sense, you grab these two, and we're going to put them into this formula right here. So it's going to be N2, because nitrogen you have 2, 1 mole of nitrogen turned into 2, and O5. So your empirical formula is N2O5. And that's how you do that. Alright, so for the next question, I'll just do about 3 overall. This is the second one. So the second one reads, calculate the empirical formula of a compound that has a percent composition of 36.1% calcium and 63.9% chlorine. Again, your questions basically I just give you basically the percentages or the percent compositions of each element. Your job is to find the empirical formula, which is this important part right here. Okay, guys? So that is the only thing that I have for now. Let us get to the solving portion. Alright, so now that I got my pen and my periodic table, now I can stop wasting time and get to the question. So we want to get these two numbers and change them into grams, because we want to eventually change them into moles. So 36.1 grams times, and then the line, we are dealing with calcium. Now remember, we do not know how many calcium atoms we have, so in the periodic table, the molecular weight of calcium is going to be 40.1 grams over 1 mole. Now, when we do the math, it is going to be that of 36.1 times 1 divided by 40.1, equaling that to 0.9 moles of calcium. The next one is going to be 63.9 grams times, then the line. Calcium, we do have that of 35.5 grams over 1 mole. So the mole, remember, they do need to be opposing of what we have, because we have grams here, so the grams do cancel out, leaving our answer in mole. So for the next one is going to be 63.9 times 1 divided by 35.5, which gives us an answer of 1.8 mole of chlorine. Alright, so now that we have the calcium being at 0.9 mole and chlorine at 1.8 mole, between these two you do have to again choose the smallest one, and obviously the smallest one is going to be for calcium. So we're going to do calcium equals that of 0.9 moles of calcium over the smallest number between those two being that of 0.9. The same thing's going to happen for chlorine. But instead of putting 0.9 on top, we're going to put 1.8 mole of chlorine. And on the bottom, we're going to put 0.9, again, because it is the smallest value. So 0.9 over 0.9 should give us that of just 1 mole of calcium. And the other one's going to be 1.8 divided by 0.9, which should give us an answer of 2 mole of chlorine. Now note, in the first example, we did get like a 1.5 or something like that, or a 2.5. In this one, they kind of gave us a really good estimate of a whole number. So in a sense, these two, when we put it into a formula, should be that of calcium, which is just 1. Again, we do not put anything there because it's insignificant. If we put it there, that means we do have 1 already. And then Cl2, because we do have 2 moles of chlorine. Hence, your answer is going to be calcium chloride. This is the last example I am going to give you guys, which does have that of 3. I know some of your questions do have 3 of them. So this is basically, again, the same thing what we've been doing for a 2 elemental structure or a compound. But now, instead of just 2, we're going to do 3. So hopefully I could sum this up real quick, just because again it is the same process. So again, we get the same thing. Let us start off with carbon being that of 40 grams of carbon times, and then the line. In the bottom, we're going to put again the molar mass of one carbon atom, which is going to be that of 12.0 grams. On top, we are going to change it into moles, so we are going to give it a mole. The next one is going to be for hydrogen, which is going to be 6.7 grams of hydrogen times, and then the line. In the bottom, the molecular weight of hydrogen is going to be that of 1.0, and on top we're going to put 1 mole because we want to change it into mole. Then the last one is going to be that of 53.3 grams times, and then the line. In the bottom, we are going to put the molecular weight of one oxygen atom, which is 16.0, and on top we're going to put 1 mole. Now let us do the math for each and one of these. So for the first one, 40.0 times 1 divided by 12 would be, or give us that of 3.33 moles of carbon. In the bottom one, or the second one, 6.7 times 1 divided by 1 should again typically give us that of the same number, which is 6.7 mole of hydrogen. Then the last one, 53.3 times 1 divided by 16 should give us that of 3.33 mole of oxygen. Now, continuing that we have again the same numbers, let's see what we get when we want to change this and see what we get as a molecular compound. So now that we got the moles for each individual element for carbon, hydrogen, and oxygen, we do have that of similar moles for carbon and oxygen. Now, as you could see, between 6.7 and the 3.33s, the 3.33s are obviously the smallest one in a number line. So we are going to divide each individual element by 3.33. Now, does it matter which one? No. As you could see, they are the same number. So it doesn't matter where you're going to get the smallest value. So for the first one, we are going to do carbon, so 33, or rather 3.33, my bad. 3.33 mole of carbon over that of just simply 3.33 will give us that of 1 mole of carbon. The next one, we are going to put on top 6.7 mole of hydrogen over that of 3.33. This is going to be for hydrogen. I did not have enough space over here for carbon, but just follow along. So 6.7 divided by 3.33 should give us that of 2.01 mole of hydrogen. And then the last one is going to be for oxygen, which is going to be relatively the same as the one on top. But note, you still have to do the work because you never know. 3.33 moles of oxygen and 3.33 moles of carbon are very different. So that would still be 1 mole of oxygen. Now, as you can see, we do have 1 mole of oxygen and 1 mole of carbon. So, in a sense, or in order, we could say that we do have C, H. Now, as you can see, H does have 2.01. All you need to do is round it. As you can see, it's clearly closest to just 2.0. So it's going to be CH2O. That would be your answer for this question right here. So the empirical formula is going to be CH2O. With that, we are basically done. Again, sorry for the late video. I am honestly really busy. But I finally got to it. If you do have any questions, let me know back in Google Classroom. Okay, guys? With that, I will try to do another video for the next assignment, or basically the next topic for like later on this week. Again, I'll catch you guys then.